So to recap, 1 radian is a little less than 60 degrees because if I took an equilateral triangle, right, which has all the sides the same, and I bent the one side a little bit so that it matched up the same curvature as the circle, that would make that angle a little bit smaller. So now we have an estimate that 1 radian is a little bit less than 60 degrees. But as a pre-calculus student, you've been like, you can't round until the end. We're all about precision. So if we have a definition that's like a little bit less than 60 degrees, that kind of bothers us because we kind of want to know what it is exactly. Okay? Well, radians are related to arc lengths. So if we can figure out how many arc lengths are in a circle, we could compare that because we already know how many degrees are in a circle, and every arc length is 1 radian. So now I'm going to take this measurement, I'm going to mark it in purple here. This was 1 radian. If I estimated it again, that would be 2 radians. Estimating that distance again would be about there for 3 radians. Okay. Again, you should be a little bit frustrated because you're like, Mr. J, I'm not feeling like this is very precise because you're estimating. Okay. But as I estimated, can you see if I counted, I would get 1, 2, 3, 4, 5, 6 and a bit. There we go. Let's bother ourselves just a little bit. There are 6 and a bit. A bit is just something small. There are 6 and a bit radians in a circle. Again, that should make us feel a little bit awkward because it's not very precise. Are you ready to get precise? Okay. So now if I think that there are 6 and a bit radians around a circle, as I'm going around the circle counting these, what am I actually counting when I go all the way around? What is that called, all the way around a circle? Circumference. Okay. And we have a circumference formula, and probably you've never really thought, you've never really thoroughly thought about formulas, but formulas are always relationships. So my circumference formula is this. It is a relationship between circumference and radius. If I put this in brackets, what number is that? That's an exact value. 2 pi is an exact value. But if you estimated that, what would you estimate that to be? 3.14 times 2, 6.28, 6 and a bit, right? Does it make sense if there are 6 and a bit radiuses, it comes out to 2 pi? Exactly. So we can now take this statement since there are exactly 2 pi radiuses in a circle, there are exactly 2 pi radians in a circle. And I don't know, but it often happens, and maybe this happened to you. Did anybody ever get the area of a circle formula and circumference kind of mixed up? Because they're very similar, right? Area is pi r squared, circumference is 2 pi r. They both have a pi, they both have an r. One has a tiny little 2 and the other has a 2 in front. Oh, they're so similar, so easy to mix up, okay? Maybe if you think of this as 6 and a bit radiuses and think of this diagram.
Can I please have Brian Pye to the office?
Yeah, he'll be right down. Maybe that can help you remember this formula a little bit better. Okay? Now, we can now think about stuff being exact. You know that 2 pi radians is equal to exactly 360 degrees. Halfway around the circle, 180 degrees. How many radians is halfway around the circle? Pi. Does it make sense that 2 pi is all the way around the circle? That halfway around the circle would be pi radians? And if you wanted to find 1 radian, you could go to your calculator and you could either take 360, you could either take 360 and divide it by 2 pi, and I'd like you to try this on whichever calculator you have and see if you get this number, or you could have taken 180 and divided it by pi. But I want you to try the 360 divided by 2 pi because I was showing this to my grade 10 students the other day. There's a common mistake that's often made in that calculation. If you do the common mistake, which looks like this, you get the wrong answer, right? Looks like I typed in everything right. Why is it when I push enter, I get the wrong answer? Because your calculator knows order of operations. The second one that I wrote, it divided it by 2, got 180, and then said, what do you want to do next? Oh, you want to multiply by pi? So this took 180 and multiplied by 3.14 and more decimals. So if your calculator doesn't let you do fractions, you would have to make sure that you put brackets around that 2 pi to get the right answer. 57.296. That's the wrong one. Oh my goodness. There we go. So when we said a little bit less than 60, now we know exactly how much left than 60, right? The exact answer to this is 180 degrees divided by pi. That is going to be super helpful. In fact, they have it at the top of page 489 and, oh, there it is. And on the top of page 489, you have this. I'm going to say that I'm going to highlight this one. That one I find is the most helpful. From that one, you can get this formula in purple just by dividing both sides by pi to get 1 radian by itself. Right? If I know what pi radians are, I can divide both sides by pi and find out what 1 radian is. It also will let you find this formula in orange. If I know what 180 degrees is, can you see that you could divide both sides by 180, and you would get 1 degree is pi divided by 180. And we're going to use this to convert back and forth between radians and degrees. Now, from our activity yesterday, and I'd like you to put this on the side here. From our activity yesterday, we figured out our formula for arc length in degrees. First of all, I don't know why they decided this, but on your formula sheet, they use the letter S for arc length. Yeah, I can see your brain's working. It's nothing is coming to me quite. I'm not quite sure how the letter S relates to arc length, But they probably wanted to avoid A because what do you use A for? Area so many times. So it's like, let's avoid A. What's after A in the alphabet? S. Perfect. I'm sure that's how they decided. So they use arc length, and we figured this out, and I love this formula, that it was a proportion of your circumference. Since there are 360 degrees in a circle, whatever arc is subtended by an angle, so whatever angle you have, that's the percentage or proportion of the whole circumference you're going to get for your arc length. It's a beautiful formula because it just makes sense, and because it makes sense, it's really easy to memorize. It's also not on your formula sheet. So if you want to use the arc length formula in degrees, you have to have it memorized. So it's nice that it's easy to remember. But we are also now going to do the arc length formula in radians. And the arc length formula in radians is super easy because it's the same idea, but now theta is in radians instead of degrees. 360, what will I write instead of 360 degrees? I will write 2 pi radians, and I'll still have my circumference. This formula in this form is not on your formula sheet, but it's also easy to remember, just like the original formula. This formula is on your formula sheet because mathematicians looked at that formula. And you know how I said I don't like simplifying this because it makes so much sense? When mathematicians saw this formula, they could not help themselves. It simplifies so nice. Do you see that that 2 is going to cancel out with the 2? And the pi is going to cancel out with the pi. Because it simplifies so nice, this formula is on your formula sheet for arc length, but it only works in radians only. And if you try to use that formula in degrees, you'll just get the wrong answer. Because that only simplified because you had the 2 pi on the bottom. All right, with that, we are ready for example number 1. Okay. And we want to find and convert. So we're going to talk about converting. And I'm going to show you a couple of ways of converting. Okay? Method number 1 is to convert between radians and degrees and radians. You are either going to multiply by pi over 180 or 180 over pi. This might be problematic because they're so similar. So for example, if I want to convert 170 degrees to radians, I will multiply by pi over 180 because on the formulas that we had from before, in the orange box, we had that 1 degree was pi over 180. So 170 degrees, I would have to multiply by pi over 180. The problem with this technique, right, sometimes you're going to multiply by pi over 180, sometimes you're going to multiply by 180 over pi. Chances of you mixing that up are quite high. So a couple of things that can help you not mix it up, okay? Whenever you're doing a conversion and you're multiplying, what you multiply is a fraction that has 1 unit on the top, in this case pi radians, and 1 unit on the bottom, in this case 180 degrees. And what you're multiplying by is equal to 1. Even though the numbers are different, 180 degrees is exactly the same as pi radians. So when I divide them, this whole fraction is equal to 1. What this allows you to do is it allows you to change units. You've done this before with like feet and inches, okay? For example, if I ask you, how many inches is 2 feet? Do you know how to change it? How many inches is 2 feet? 24. What did you do? You multiplied by 12. So you knew you had 2 feet, you multiplied by 12, wow, that's an 11. There we go. 2 feet, you multiplied by 12, but what you didn't actually have in your head is you actually had this fraction 12 over 1. And 12 inches is equal to 1 foot, so it's equal to 1. But what ends up happening is your units of feet canceled out, and you get 24 inches. But it was so intuitive for you that you never even think about the units. But the units can actually be really, really helpful for any kind of conversion. For example, right now, 170 degrees, notice my degrees. If I want to know which one is on the bottom, the 180 needs to be on the bottom, so my degree signs go away. And then I get, as an exact answer, 170 times by pi over 180. And again, in grade 12, if you do not reduce your fraction, no deduction. Right? If this was multiple choice, can you see that they would probably reduce this to 17 pi over 18? But perfectly fine to leave it as 170 pi over 180. Nice. If you reduce it and you make a mistake, I have to take off half the mark. Okay? This is exact. And what are the units that are left? The units that are left, we canceled out the degree units, we're left with radians. Typing this into our calculator, what is 17 pi over 18? Approximately 2.967 radians. And that is an approximate value to 3 decimal places. I read my question again, and I'm like, oh, they wanted to the nearest hundredth. So as a rule of thumb, when you round, always do 3 decimal places, then read your question again, because if you don't round to 3 decimal places, you lose a half mark for rounding. Unless the question told you to round to something else, then if you don't round to that, you lose a half a mark for rounding. So it's rounding is not hard, but again, it's checking to see if you're paying attention. Did you read the question again? We'll check if you pay attention to that precision. So here they want it to the nearest 100. Okay? This idea with units is super powerful. Okay? Even for changing money. Most people, the most likely time that you change money is if you travel to the United States, because it's the closest country. Some of you will travel to farther countries and go back, right, to Europe, and you have the euro and the Canadian dollar, or you're used to one price over another. But, for example, does anybody know what the current conversion for Canadian dollars to US dollars is? About. Anybody go to the United States lately? Okay. All right. About 1 Canadian dollar is about 75 cents American. So we could take that, and you could make either this fraction or you could make the fraction like this, right? Because either of these fractions is equal to 1. Okay? And depending on the website you look at, maybe somebody else looks up and finds out, oh, $1 is $1.33 Canadian. That's a different kind of fraction that you could also set up with 1 on the top, 1 on the bottom. But now you have the ability, if you just know one conversion, you could either say, I have 10 Canadian dollars. How much US will I get? Well, if I have 10 Canadian dollars and I want to figure out US, I would use this one and multiply it by 10 Canadian dollars. My units would go away for Canadian. 10 times 0.75 would give me 750 American. Very nice. If I had 10 American dollars and wanted to know how much Canadian that would be, I would use this one and take my 10 US dollars, so my US dollar units cancel. I'd have to take the 10 and divide it by 0.75 and get my conversion that way. Okay? So I find you're going to either multiply by pi over 180 or 180 over pi, but it will be obvious if you understand how units work and you understand that this is equal to 1. So I hope that is very helpful for you. Okay? The other method of converting is some people just like to start off with a statement that they know is true, like this one. Okay? Then, if they start with that one, they can get to 1 degree by dividing by 180. And then they can get to 170 degrees by multiplying by 170. So you're just starting with something that's true and dividing and multiplying until you get what you want. Also very helpful, because now instead of remembering pi over 180 and 180 over pi, you just remember one thing, that 180 degrees is pi radians. And from that, I can multiply and divide to get any unit I want. And at the beginning, you're going to be wanting to do a lot of converting because you're going to get stuff like part B. Here we go. Scroll down. And part B wants us to convert negative 12 pi over 11. It wants us to have degrees, and it wants us to sketch. We'll do the degrees part first. Technically, this is radians. So if I want to convert this to degrees, I'm going to multiply by 100 degrees over pi radians. So my units cancel out. Something very cool is that the pi's in this situation will simplify and cancel out. And I am left with negative 12 times 180 over 11. So I'm just going to go to my calculator. 12 times 180. And does it ask us to round to the nearest tenth? So a rounding error is an E6 error. Okay? For getting the units is an E5 error. So if you write an answer in degrees, you need to have the degrees sign. Notice so far I've only been writing out the word radians in full. Does anybody know the abbreviation for radians? You guys are amazing. Nobody said anything. It is true. There is nothing for radians. You are all so intelligent by not saying anything at all, right? It's not this like, that you did that on purpose, right? It wasn't this like, I don't answer teachers' questions kind of phobia or anything. Like it was like, I knew it was nothing, so that's why I said nothing. So when we write an angle, like in the first answer, I've been writing out radians partially because I want to show you that the angles disappear. But the answer to this first one, if you just wrote 2.97, that is correct. And it feels really weird that there is no units, even though there is a unit associated with it. So for whatever reason, this is the one thing mathematicians have decided, if you're talking about an angle and you don't include units, you mean radians. Okay? So in grade 11, when you didn't write a degree sign on your trig test, 180 degrees is half of a turn. But when you didn't write that degree sign, you actually wrote 180 radians. Since there's just over 6 radians in the circle, that's almost 30 full rotations around the circle, right? So if I'm skiing and I say I just did a 180, and I mean radians, that's insane. It'd be like practically a helicopter up in the air for a little bit before I landed. And then it wouldn't quite be perfect, so I'd probably die. So I probably can't actually tell you I did a 180, because I'd be dead. So morbid, sorry. This year I'm hopefully going to be less morbid in class, but it's already happened twice on my grade 10 class. I took a hemisphere and I cut it in half, and I colored the top red. Hemispheres don't bleed, but I made it bleed. So morbid. Sorry. Okay, try to be better. So now we've converted, oh, what did I forget? It's good that I'm checking my work. Did anybody notice the mistake I made? Negative sign, negative sign, negative sign, negative sign. There we go. That's going to be important because we've asked to draw it. We're asked to draw what does negative 12 pi over 11 look like. Well, angles in standard position, they start on the positive x-axis. If I ask you to draw negative 196 degrees, I think you'd have no problem estimating where that would be. So this is also the estimate for negative 12 pi over 11. But I also want you to start thinking about doing measurements in radians. Okay? Most of our radian measurements that we do with exact values, not all, but most of them include a pi. And the reason they include a pi is because there's 2 pi radians, like here's 0, all the way around is 360, so I'll put comma 2 pi. Halfway around is pi. So usually we're dealing with measurements of pi when we're thinking about radians. Can you see that the fraction of negative 12 over 11 pi, the 12 over 11 is a little bit more than 1. So when I was thinking about just in radians, I would know this is 1 pi, and I need to go another 1/11 more. Because 12 over 11, you agree with, as a mixed fraction, that's 1 and 1/11. So now I imagine taking this extra pi, splitting it into 11 equal sections, and that would tell me there. But I have to sort of visualize 11, 1, 2, 3, 4, 5, 6, 7, 9, 10, 11. Perfect. I split that up into 11 equal sections, and I took one of those 11 sections, and it works out. So that's how we imagine it in radians. We're thinking about fractions all the time. But for now, if you want to convert it first to degrees, because that's easier for your brain, perfectly fine. So it's going in the negative direction because we had a negative angle, and there we have negative 12 pi over 11. Okay, there's also the following. There's a shortcut for changing from radians to degrees if there's a pi. Okay? Shortcut is because pi radians is 180 degrees, you can just replace the pi with 180 degrees. Okay? I'll show you the shortcut, and I'll show you why it works. So the shortcut, if I had 3 pi over 4, in radians, this would equal 3 times 180 over 4 in degrees. And we could reduce this if we wanted to 135 degrees. Why does that always work? Well, if you did the actual way of multiplying by, and you'd have degrees on top and radians on the bottom, your pi's would cancel out. So it's like the pi is just being replaced with the 180, but it saves you the step of having to write the extra and cancel things out. You just have to replace the pi with 180 as a shortcut. It's kind of nice that way and helpful. So then in part C though, can we use the shortcut? No. Part C, we start off with 7.5 radians. We can't use the shortcut because there's no pi, so we would have to multiply by 180 degrees over 1 radian. And again, I'm writing it out again as a reminder that we want those units to cancel out. So I go to my calculator, I just take 180, multiply by 7.5, and I get 1,350 degrees. Nearest tenth of a degree. Do I even have to, did I do something wrong? Seems kind of funny that they're asking me to round. I guess we could check the answer. Does he ever get that where they ask you to round something and then the rounding isn't there and you really feel like something went wrong? So we can, I mean, even these answers are at the end of the answer section. So this is number 1, D. Oh. Something, well, they have an answer, but it's totally different. Theirs isn't rounded either, but theirs is just nicely 430. So I feel like something went terribly wrong.
Gonna divide by pi.
Oh, 180 degrees is in 1 radian. 180 degrees is pi radians. Wow. So I still have to divide this by pi. This would be the exact answer. Man, I just like totally wrote something down wrong. We divide that by pi. And then we have something 429.7, which rounds to 430.0. Then, oh, perfect. 29.71, but it was rounded to the nearest, 429.7. It's actually, the answer key in the back is wrong. Boy, this question has a lot of things happening. First, I made a big mistake. by not having my ratio correct, right? 180 divided by pi. Which once we found that wasn't a problem, but the answer key we just discovered, they rounded wrong. It's supposed to be to the nearest tenth, which would be 429.7 degrees. All right, so if you get something where it asks you to round and something's not quite right, it is good to check to see, did we make a mistake? And in this case, we did with our 180 over pi. Okay, questions to circle are 4, 5, and 7.